Hi everyone, how are you guys doing? So today we'll be solving the last question of our bi-weekly contest. Find the number of subarrays where boundary elements are maximum. So it is given you are given an array of positive integer nums. Return the number of subarrays nums where first and last element of the subarray are equal, and it is the maximum of that subarray, right? So basically they are saying, let's say for 14332, for 14332. For 1, it should be 1 only. For 4, it should be again 4 only because there is no other 4. So there is no subarray which can have both start and end as 4. But for 3, there is this subarray 3 and 3 again. So 1 plus 1, 2. Then again, this 3 alone also stands there, and then 2 again alone stands there. So basically, what we need to do is we can iterate over the first element. We can iterate over the starting of the subarray, and what we need to do now is we need to check the next greater element. So the next greater element is, let's say, at index j. Then till j minus 1, all the elements are less than or equal to j. Right. So let's say if there were okay. So let's say for 3, the next greater would be here. That is the an imaginary element of with index n. So it means that 3 will have this 3 starting from this 3. There will be a range of this many elements in which we need to find out how many threes are there. So in this range there are how many threes. So basically if this is our j, that means that j is greater, so we need to point here only, j minus 1, right? J would be greater than 3, right? So we need to point here, because we find the next greater. And once we find j minus 1, so from this I to j minus 1, we need to find out the frequency of 3, right? So that is basically what we do. Why frequency of 3? Because the starting and the ending elements would be 3 only, right? So the number of elements starting at I and ending at some other point is the frequency, right? Frequency of in between I to j minus 1 of 3. So now we need to think how to calculate, because we know that we can easily calculate this j in O of n using stacks next greater, right? So now we need to understand how to calculate this frequency of 3, because the constraint is greater. It is 10 to the power 9. So what we do is we create a hash table, and in that hash table what we do is we store the index of each of these elements. So basically in that hash table we have key as the value, and the value as the as a vector of indices. So 0 is there. Then for 4, what do we have? Again 1 only. For 5, what do for 3, what do we have? 2 and 3, right? So something like this, we create a hash table. And now what we can do is, now we can do an upper bound and lower bound in this range of I and j minus 1, and calculate how many elements are there in that map of, let's say, we need to find out how many elements are there from L to R in nums of x, like which ends with nums of x. So basically we need to find out the frequency of nums of x in between L to R. So what we need to do is, now we have, when we say MP of nums of x, that means it is a vector. It stores all the indices of all the positions of, like, basically x, which we have nums of x, my bad. So what we need to do is we need to do an upper bound and lower bound using I and j minus 1, basically, and calculate the difference, and that will be the number of elements, right? I guess you understood what I'm trying to say. So basically, what I did here is, so at first I created a nums array of, well, it is already created. So I found out the size. Then I created a hash table of key as the int and value as the vector, and MP of nums of I equal to a dot pushback of I, right? So basically we are pushing the index. Now we have stack st, And we also now we how I now we need to find out the next greater. It is basically the monotonic stack method. If you don't know, basically what we do is, in the stack, while the stack is not empty, as we need to find the next greater, that is why we are starting in a reversed method. So after that, what we do is, while the stack is not empty and nums is less than or equal to nums of st dot top is less than equal to nums of I. So basically our condition should be that we need to find the next greater, that is nums of st dot top should be greater than nums of I, right? So unless we find that, we can pop all the elements because none of them would be greater than nums of I. And once we find it, we can store it here, and if the stack is empty, then we say it is n. That is basically it is an imaginary element after the n minus 1th element, that is the nth element, right? And we do this. Now what we do is, we say our answer is long answer equal to 0, and after that this we find out x, which is the nums of I, and then we find out j. J is the next greater element for I. So next greater of I is j, and after that we do j minus minus, because we need to find out from I to j minus 1, right? So I did a j minus minus, and we need to calculate in between I to j how many elements of x are there in MP of x. MP of x is a array which stores all the frequencies of x, right? So that is what we need to find out. So how do we do this? We just find out the lower bound, then we find out the upper bound, and then we just subtract it. So let's understand how this works. So let's say we have 3, right? So 3 stores 3 stores a vector of 2 and 3, right? 2 and 3. Uh, Now when we reach at 3, this is 2, 3, 4, and then 5. So our j will be 4. Our j minus 1 basically will be 4. So in this, so our L will be 2, L will be 2, and R will be j minus 1, which is 4, right? So in between 2 to 4, we need to find out. So what is the lower bound of 2? This lower bound of 2 is this, right? So what is the position of that? 0. What is the upper bound of 4? It is at the nums dot end, right? Not nums dot end, vector dot end basically. So upper bound is this. Basically, index would be 2 because this index is 1. So how many elements are there? There's a subtraction of this, right? So you can also understand in this way that if we find upper bound, that means it is definitely greater than or equal to r, right? Now, greater than r, sorry. For upper bound, it is greater than r. So, but we need greater than, less than or equal to r, right? So if we move on to this minus minus, that is 2 minus minus, then we will reach 1, right? Then 1 minus 0 plus 1. So L r minus L plus 1 is the length of the subarray. So that is why 1 minus 0 plus 1 would be 2, and hence we find out in that way. Even if there would have been 1 in here, that means this would also have been 3. Then in this case also the lower bound would have been here only, and the upper bound would have been here only. So we would have calculated 2 only, right? So you understand how we calculate this using binary search, as these will be in increasing order only, hence this takes log n time. So our time complexity will be O of n into log n, and our space complexity will be O of n, right? I hope you understood. Let's submit this. I'll also show you after getting an accepted. So yeah, that is how we solve this question. Thank you for watching this video. I hope you really like this. If you liked it, please smash the like button. Thank you.